what the surface of Venus looks like. Here are the pictures. The bottom one is Earth to kind of give you a reference, and then the top one is Venus. Look at Earth, just because we kind of know what Earth looks like, so it's a good reference point. This is false coloring, right? So the blue actually means that it's deep, and the white means that it's high, right? The white doesn't mean it's snow, and the blue doesn't mean ocean. It just means the depth, right? Blue is deeper, white is higher. So if you look at Venus, again, the blue is deeper, white is higher. And then the grays are the intermediate. So you can see Venus does have high points, it has low points, and it might have kind of lowlands, rolling hills, a whole bunch of different features. What's also interesting is if you define continent by a certain height, what they're actually saying is Venus has about 8% continent. All the rest would be the lower elevation. Now, the mountains on Venus are actually similar height to the mountains on Earth, which is why you can kind of use the same scale between the Earth and the Venus. Now, on Venus, we have volcanoes. Quite a few volcanoes. Actually, the volcanoes are active and so numerous that they actually cover the entire surface of the planet every few 100 million years. The entire surface is just recovered. The mountains, or the domes, can get to 25 kilometers across. Now, what kind of volcanoes? Think Hawaii. Those nice, kind of big domes that have flowing red hot lava out of them. That's the type of volcanoes that are on Venus. So on Venus they have calderas. Calderas on Earth are a crater that's 1 kilometer big. And here they're craters on top of the volcano that are big. So 1 kilometer big. Basically what happens, but a good majority of the lava comes out of the magma chamber. And so there's not enough pressure to hold up the rock. And with the gravity being comparable to Earth, the rocks just collapse into the empty chamber. And so those are called calderas. Gala-Moons is the largest shield volcano on Venus. Not the largest shield volcano in the solar system, that's actually on Mars. And shield volcanoes are what are, the Hawaiian kind of volcanoes. Now these are interesting, coronae. They're the largest volcanic structures. They're circular. And basically they're bulging upward. So it looks like it should be a crater, but it's coming up. It should be a caldera, but it's bulging up towards it. And why is it bulging? Because the magma chamber underneath is moving up. So this is one of the coronas. And you can see little lava domes in it. And I shouldn't say little. They're fairly large lava domes. The corona is super large. So it makes these lava domes look small. Now, volcanoes on Venus are still active, and we have evidence of this. And it's fun evidence. Sulfur dioxide levels can peak. And when that peaks, it means there was a volcanic eruption, and so you can see or detect that it's happening. The other fun thing is lightning. And this does happen on Earth. When a volcano erupts, lightning can occur. And so on Venus, the same thing is happening. We're getting lightning and bursts of radio energy, which is indirect proof that volcanoes are still erupting on Venus.
It's hard to land on Venus, but it's not impossible. The Soviet Union did it 4 times with the Venera landers, and that's what we're talking about today on Vintage Space. In my last video about a 1966 proposal to send a manned mission to Venus using Apollo-era hardware, a lot of people said that it would be completely impossible to send men to Venus. They pointed to the Venera landers as proof. The Venera landers lasted about an hour on the surface of Venus before succumbing to the hellish environment, the absolutely insane temperatures up to 900 degrees centigrade, and crushing atmosphere that's about 92 times as heavy as we feel our atmosphere on the Earth. But the Venera landers were by no means failures. They actually accomplished exactly what they set out to do, and they did it spectacularly. So let's look at what they actually did. When we think about a race in space, we tend to think about the race to land a man on the surface of the moon. But there were other things that both the Soviet Union and the United States were after to score as first during the Apollo era. Among them, the Soviet Union wanted to be the first nation to send back a picture from the surface of another planet, and that planet was Venus. The program that saw this goal realized was the Venera program, and the first mission to attempt a landing and take that picture was Venera 9. Venera 9 launched on June 8th of 1975 on a Proton booster from the Soviet launch site at Tyuratam. 4 months later, it became the first spacecraft to enter into a permanent orbit around Venus. The lander separated from the orbiter and began its descent, sending information about the atmosphere back to the orbiter the entire time. The lander was actually designed to take advantage of Venus's atmosphere, specifically its dense clouds, as a braking mechanism so that it didn't need to use all parachutes and aerobraking. The lander's bottom was flared with panels that both shielded the braking engine and also acted as an air brake. 40 miles above the surface, 3 drogue parachutes deployed to pull out a small metallic parachute. That chute fell away about 31 miles above the surface, and from that point on, the thick atmosphere was enough to slow the lander. In final descent, a compressible metal donut-shaped landing cushion deployed to ensure a soft landing, aided by shock absorbers. Venera 9 touched down on October 22nd of 1975 and transmission started immediately. Protective covers dropped away from the camera lenses that were shielded behind a nearly half-inch thick quartz window, but only one of the 2 cameras worked. And it turned out the lander actually touched down on a raised area, not a flat area. So instead of seeing a straight 360-degree panorama from around the lander, we actually see a sort of half circle looking down on the horizon. Temperatures rose steadily inside Venera 9 from the moment it touched down on the surface, and by the time the internal temperature reached about 60 degrees centigrade, transmission ceased. But not before sending back a phenomenal image of the surface of Venus. These surface images of Venus might not be the most impressive we've gathered of all of space images, but they're some of my favorites because they're just sort of incredible what a spacecraft had to go to get it. What do you guys think about it? For a little bit more on the Venera program, but mostly some fantastic pictures of Venus and the surface of Venus, check out my latest post over on Vintage Space. It's linked below. And for Vintage Space every day of the week, follow me on Twitter as AST Vintage Space. And with new episodes going up every Tuesday and Friday, do not forget to subscribe right here so you never miss an episode.
I really like the video that was just playing, and if you skipped it, go back. It talks about the fact that we've actually landed on Venus. Melted. Landed a robot, obviously, that then got melted and crushed. But the fact that we were able to land in the heat and pressure is incredible. All right. Anyway, you can also see impact craters. Right? Big circular objects. All right. Meade is the largest impact crater on Venus. The next video actually shows a little bit more about the atmosphere if you were to stand on the surface of Venus and look out what you would see. Venus is just incredible.
So, if a traveler to Venus could survive the acidic clouds, the lightning bolts, the toxic air, and the heat, just how would the Venusian surface look? Volcanologist Jeff Burns with the United States Geological Survey, or USGS, circles the globe to understand what drives volcanic activity on the inner planets. When Burns imagines the surface of Venus, he considers the dark, eerie wasteland of Kilauea's lava fields on the big island of Hawaii.
It's very instructive to be able to come here and study this volcano to compare it to volcanism that has occurred on the surface of Venus. We can actually come out here to the field and study things. We can actually take samples and look at them in detail.
Geologists expect the amount of volcanoes on Venus far outnumbers the 1,500 or so on Earth.
Some estimates range from 100,000 to over 1 million volcanic features on Venus.
With that many volcanoes, lava rock makes up 70% of the Venusian surface, just like it makes up much of Kilauea's terrain. The ground becomes solid when the lava cools into hard rock.
Having a rock on Earth is our best analog for trying to understand rocks on the other planets. Basaltic rocks are the most similar to the Venusian plains.
Basalt is the most common type of lava rock found on Venus and throughout the inner solar system. The minerals freeze into glass and small crystals, a total transformation from what lava looks like when it streams out of the volcano.
When lava is actively flowing across the surface, it's incandescent and typically looks red. Now, quickly it'll form a silvery sheen over the top of it, and then over a period of a few weeks will turn black, such as the lava we see around me here.
At 5 miles high, Mont Mons is the largest volcano on Venus. And it's left some tremendous lava channels in its wake, just like Kilauea did.
Now, as you can see, the structure, we have levees here on the sides, and then internal structures as well. This is similar, perhaps, to how large channels called canali formed on the surface of Venus. However, they formed at a much larger scale.
Large enough to create seemingly endless miles of canali across the Venusian landscape. Consistent in both width and depth, the canali are much longer on Venus than on Hawaii because of environmental conditions on the planet. The dense atmosphere and hot temperature slows the magma from cooling into solid rock. And with little wind and no rain to further cool the magma, lava can cut through the surface for months after an eruption before it hardens.
On Venus, if you did see layering, you would expect to see layer after layer of volcanic rock that would all be relatively black and basaltic in composition. You would probably see little bits of color due to potentially oxidized iron, which would look red. Typically, basaltic lava flows are glassy enough that, in fact, you would actually cut your hand. They can be extremely sharp. They tend to quench and form glass.
And then there are the skies. That heavy Venusian cloud cover diffuses most of the direct sunlight.
So it would be a lot darker on the surface of Venus during the day than it would be here on Earth. Also, because the light is scattered very efficiently, you tend to lose shadows. So everything is lit fairly consistently across the surface. And then additionally, because of the composition of the atmosphere, everything would tend to have more of an orangish tinge to it.
Besides canyons, jagged mountain ranges scrape the Venusian skies. The planet's highest peak is on Maxwell Mons.
Maxwell is about 35,000 feet high, which puts it at a healthy distance above Mount Everest or any mountain on Earth. Everest is something like 28,000 feet high. So it's definitely larger than anything on Earth.